Hi, I'm Gracie.
And I'm Annabelle, and today we're doing a strong acid
Plus strong base
titration! First, we need to know what's actually happening inside of our titration.
And don't forget that net ionic. And this is everything canceled out. First, we have to get into our lab equipment.
Okay, so we have our goggles, our coats, and then our gloves. And then we also make sure we put our hair back, if you have long hair.
Now it's time to set up our titration.
We're gonna rinse our burette with NaOH so our standard won't be diluted.
Now we're gonna fill it with the same NaOH. Make sure to record your initial volume of NaOH in the burette.
Then you're gonna measure out and record the volume of your unknown molarity of HCl solution.
Pour it in the beaker.
Next, add 1 drop of your pH indicator, and for this we're using phenolphthalein. Then add your stir bar, and then add some distilled water so that your stir bar can have enough liquid to mix it. There's not a specific amount you have to use, just enough for it to be able to mix.
Then connect your Bluetooth pH probe to your computer.
So for our final setup, we should have your burette, your pH sensor, which you attach to here, and then your beaker with your acid. And then turn on your stir bar to about 6. And before you start adding your NaOH from your burette, you're going to keep and collect your first pH and volume data point.
Usually first you would do a fast one to find out where your equivalence point is, but we're just going to do one. We're going to start by adding 3 milliliters of NaOH at a time.
Add NaOH, you're going to record your data point with how much volume you added. The more data points you take, the smoother a curve your line will be. And once you start getting closer to the equivalence point, it'll start to turn more pink. And then your curve will start getting higher. And then you can see we've hit the equivalence point by the pink color.
So from the titration graph, here's what we know. We know we used 50 milliliters of NaOH and 20 milliliters of acid, but we don't know the molarity of HCl. So we're going to use the M1V1 equation equals M2V2 to solve for the unknown molarity.
Now we're going to solve our equation.
Now, a common question that students usually ask is, why can't we use the M1V1 equals M2V2 equation? And that's because in a titration, at the equivalence point, moles of the base equals the moles of the acid that was originally in the beaker. So, using our stuff from the equivalence point, and we can use molarity times volume, because molarity is basically just moles over liters, and your volume is liters. Those two things cancel out, and we can find M2. Now, some people may ask, what is the real-world application to titrations? Well, when we were originally doing this project, it was told that the molarity of HCl was 0.1, and we were really confused. So when we solved, and we figured out it's actually 0.27, we need to make this 0.27 so other students aren't confused.
Thanks for watching.
Hope that clears things up.